Hello everyone, myself Nikhil. Today we are going to know about phases of compiler in automated theory and computation. We will know about level by level for each phases. We see about the index, what is the compiler. Second, different phases of compiler. First one is lexical analyzer, analysis. And next one is syntax. Next one is semantic, intermediate, code optimization, and code generation. Later comes conclusion. First we will go over compiler. What is a compiler? A compiler is a specialized software program that translates high-level source to within a programming language into machine code or an intermediate code. The purpose of compiler is to facilitate the execution of a program on a computer. It serves an intermediary between the human readable source code and the machine readable code executed by the computer's hardware. The compilation process involves several phases. First one is lexical analyzer, a scanner. Second one is syntax analyzer. Third one is semantic analysis or analyzer. Fourth one is intermediate code generation. Fifth one is code optimization. Last one is code generation. First we see about lexical analyzer. Lexical analyzer, often referred to as scanning, as I already mentioned, it is also known as scanner, is the first phase of the compilation process in the context of a compiler. It involves analyzing the source code of a program to identify and tokenize the individual components known as lexemes. Let us discuss about the process. It contains tokens. Tokenization means also tokens. The process of breaking the source code into individual tokens. We see example in the next slide. Tokens can be keywords, identifiers, literals, operations, and functional symbols. Lexemization, the basic building blocks of the source code. Next one is regular expressions. Lexical analyzer often involves the use of a regular expression to define the patterns of valid expressions. This also we can see in the example. Next one is symbol table. During lexical analysis, a symbol table may be created to store information about the identifiers such as variable names. The table helps in managing and the identifiers and their attributes. Error handling. Lexical errors may include error handling mechanisms to identify and report lexical errors such as invalid characters or unrecognized symbols. Example about the lexical analyzer. Let us take the position equal to initial plus rate multiplied by 60. Here it contains identifiers and tokens. We can write about the identifier 1 equal to operator will be contained separately in tokens. Next ID 2 comma 2 plus operator also contains separately. It will not join with the other tokens and identifiers. Asterisk symbol, that is also called as multiply symbols, is also separately. Next one is 60 is a value int. The symbol, as I already mentioned, it contains symbol table, different identifiers and tokens helping the compilation. It contains the symbol table contains three tuples. First one is position, initial, and rate. As I already mentioned in the position equal to initial plus rate, we contain three variable names that I have mentioned in the symbol table. Next one is syntax analysis or analyzer. Syntax analysis is also known as parsing. I already mentioned in the index table that it also known as parser is the second phase of the compilation process. Its main role is to analyze the syntactic structure of the source code according to the rules defined by the programming language's grammar. This phase ensures that the source code follows the correct syntax and organized into a hierarchical structure that reflects the grammatical rules that I mentioned in the diagram. The next another two slides. Let us see about deep in the syntax analyzer. It contains error detection, structure recognition, intermediate generation. Syntax analysis identifies the syntax errors in the source code if the code deviates from the specified grammar programs to identify and fix issues. This is about the example about semantic analyzer, syntax analyzer. Sorry. First one is equal operator, that is contains ID1. Next ID1 contains the ID1 equal to plus ID2 plus next ID3 into 60. This all contains in the grammatical manner in the structural hierarchical structure. Next one is semantic analysis. Semantic analysis is the third phase in the compilation process following lexical analysis and syntax analysis. It is the both combination of a lexical analyzer and semantic analyzer. Unlike semantic analysis, which primarily focuses on the grammatical structure and the hierarchical structure, semantic analysis is concerned with the meaning or semantics of the code. This phase ensures that the program gathers the intended meaning of the programming language and performs various checks. Example of the semantic analyzer is the previous one only. Multiply symbol ID3 multiply into to float. It converts the into to float. This float means any digit last point 0. Role of semantic analysis: type checking, variable or the scope declaration, function and method overloading, syntax semantics interface, array bounds checking, constant evaluation, undefined variable and function detection. Benefits of semantic analysis: enhanced codability. It enhances the code quality, increase the reliability, optimization opportunities. Intermediate code generator is the fourth phase of the comparison process following lexical analysis, syntax analysis, and semantic analysis. It is the fourth phase of the following process of phases, different phases of the compiler. The primary purpose of this phase is to generate an intermediate representation of the source code that is independent of the source and target languages. This intermediate code serves as a bridge between the high-level source code and the low-level machine code or target code. Abstraction of a source code: intermediate code provides a higher level abstraction than the source code, making it easier to perform subsequent optimization, code generation, and steps. Platform independence, simplification for optimization, facilitation of code operations, error detection, and reporting. It is example of this. T1 int2 float is stored in the T1. ID3 into multiply T1 is stored in the variable T2. ID2 plus T2 is stored in the T3. T1 is stored in the ID1. It continues to the next code optimizer. Code optimization is a crucial phase in the compilation process that aims to improve the performance of a program by making it code more efficient. Optimization can occur at various levels, including the source code, intermediate code, and target code. Types of code optimization are mentioned below: source code optimization, intermediate code optimization, target code optimization. We see the example of the code optimization. For optimization of code, we have written semantic analyzer process into operator in T1. We reduced the above process of phase into some less lines of code. Assembly code: T1 ID3 into 60 into 2 float is stored in the T1 variable. ID2 plus T1 is stored in the ID1 variable. Next one is code generation. Code generation is a crucial phase in the compilation process where the compiler translates the optimization code into the target code assembly for a specific hardware program. It contains instruction selection, register allocation. Here the register allocation, we used 1, 2, 3, 4. As you can see, total 5 operators. First one is load operator. Load the function ID3 into R1 and multiply the both functions with the both registers stored into R2. The multiplier of 60. Again load register into ID2 into R3 and add the both registers and store it in register 4 and store register 4 into ID1. This is about the code generation. As you can see, we got end of the slides presentation. We know about all this. Thank you.